Okay, today's lesson is the straight line depreciation. A new vehicle loses around 30% to 40% of its value in the first year. Loss in value can occur through age, wear and tear, or simply by becoming outdated when a new model is released. Look at example 11. A boat was purchased for $37,800. Wow, I didn't know that was so expensive. And decreased in value by 11%. So I'll put the minus 11% because it's decreased in its first year. To the nearest dollar, what was its value after 1 year? So we want to know how much, some money. Part B, a new Porsche was purchased for $239,850 and was valued at $175,600 12 months later. So down by $64,250. What is the percentage decrease in price to the nearest unit in the first year? So this one is not finding an amount, money, it's the percentage that decreased. Let's look at the part A. Purchase price was $37,800 and decreased 11% in value. So 89% worth it of the price. But now, after 1 year later, it's 89% of the $37,800. So I'm just writing it down, all the information that I need. And then to the nearest dollar, we need to find what is worth after 1 year. So all I need is 89% of $37,800. So 89 divided by 100 times by $37,800. So after 1 year, this boat is worth $33,642. So it should be less than what you bought for. Part B, a Porsche. I didn't realize it's so expensive. $239,850 and was valued at $175,600 after 1 year, 12 months later. What is the percentage decreased in price? $239,850 take away $175,600. It is $64,250 decreased. And to the nearest unit, so no decimal. So this much decrease, $64,250 all over. What was the amount in the first place? It was $239,850. Always, the total amount is your original price that you pay for in the first place, times by 100% because we want to know the percentage. You will get 26.7875 ... But it says to the nearest percentage, so it'd be 27%. That's a huge drop. So let's sum up. In a nutshell, depreciation is the loss in value, obviously, of an asset over time. According to the results of a survey by an insurance company, a new car depreciates around 50% in the first 2 or 3 years of its life. And depreciation accounts for about 37% of the costs of running a small car and about 49% of the costs of running a large 4-wheel drive. I think it's better to stick with a small and maybe good quality second-hand car. So there are 2 methods for depreciating an item. There's a 2 depreciation, okay? So first, straight line method of depreciation, items value decreases by the same amount of money each period. The other one is a declining balance method of depreciation, which items value, sorry, it's my dog. Just wait a minute. Okay, now decreases by the same percentage each period. So that means say 10% each year, it decreases. Difference between 2 depreciation methods is one is going down by certain amount, money. The other one is going down by percentage. Because we are doing straight line method of depreciation, so we are going to deal with money. Also, it's a straight line. That means a linear function, y equals mx plus c. Let's have a look at what does that mean by mathematical formula term. Straight line depreciation formula is S equals VO minus DN. What's S? S is a salvage current value. How much is worth? VO is the initial value of the asset. D is the amount of depreciation per period. All right, and number of periods. D is amount per period. This is rate. Remember, rate is dealing with the 2 units, like $4.50 per kilograms. So you're dealing with the money and a kilogram. That is your gradient. Here, D is our gradient. Because it's a depreciation, you can expect that D should be negative. That's why it's got negative here. Remember, D is our gradient, but it's a depreciating. It's going down, so it's negative. And the VO is a constant, okay? It doesn't change like a C. The money you pay in the first place is not going to change. It's independent. Example 12. A motorcycle is purchased for $16,000. Now, that's initial amount, which is a VO. That's not going to change. And depreciates by 2,400. So this is because it's a straight line depreciation dealing with the money. Okay, it's depreciating same amount each year. And D is 24,000 each year. Can you see that dollar per year? So it's a gradient. It's M. Let's write it down. Equation here. Part A, use the straight line depreciation formula. So it was S equals VO minus DN. Find the value, that's a money, of the motorcycle after 3 years. Oh, so that's S. How much is worth it now? Part B, when. It says when. So we're looking for periods, N, to the nearest month. Okay, so not years, months. Will the motorcycle be worth half its purchase price? Actually giving us the price. It's half its purchase price, which was half of 16,000, which is 8,000. Okay, so that's information we have to use. Part C, after how many months? Also N, to the nearest month, will the motorcycle have a $0 salvage value? That means S is 0 here. Right, so we got some information that we can use for each part. Let's have a look at first one. So we have to find S. It's very important you put all the information in a nice, neat way. So S is what we're looking for, the current value, how much is worth it now. And D is rate, how much is it depreciating per year, $2,400. And N, 3 years. And our initial value, purchase value, is 16,000. The formula was VO minus DN. So S equals VO, 16,000, minus D is 2,400 times 3. Okay, that makes sense. And that will be $8,800. A motorcycle after 3 years is worth 8,800. Next one. Okay, when, so N, in month, will the motorcycle be worth half its purchase price? S is the current value. It's going to be half of what you pay for divided by 2. It's worth now 8,000. When will that happen? S is now 8,000. VO, how much you pay for, it's not going to change, 16,000. N, we don't know. D is our gradient, also won't change, 2,400 each year. S equals VO minus DN. Need to know the N. So I'm going to make N the subject. I'm going to swap VO minus DN on the left equals S. The minus DN equals S minus VO because I'm taking VO from both sides. I want N by itself is I'm going to divide it by minus D. And therefore, my N, because I'm going to cancel all that, it'll be S minus VO all over minus D. Using that, N equals S is now 8,000 minus VO, the initial 16,000, minus D. That'll give us 3.33. And then what you got to do, so it's a 40 months. It said to the nearest month need to be years and a month. Right, convert that to years. So 3 years, 36. So it'll be 4 months. Next one, after how many months? S becomes $0 now. S equals 0. D is 2,400. VO is 1,600. N, we don't know. We want it to be in a month. And the formula is S equals VO minus DN. 0, 1,600. D, the gradient, 2,400. N, we don't know. S minus VO over minus D. N equals S is 0 minus 1,600 over minus 2,400, 6.666. We times by 12 months, we get 80 months. What does that mean, 80 months? We know that it's going to be 6 years. 6 years is 72 months. 80 take away 72 is 8 months. 6 years and 8 months. It'll take 6 years and 8 months for the motorcycle to be worth nothing. The example 13, we got a table done for us. So office furniture was purchased for $85,000. Now that is our VO, how much is paid in the first place, and depreciated by $5,600 per year. Okay, so that's D. Okay, dollar per year, 2 units, it's a gradient. The depreciation schedule shows the accumulated depreciation and value for the first 8 years of its life. Accumulated depreciation is how much it's depreciating each year, but the value at the end, it's what it's worth now. 0 year, when you purchased, it's brand new, so it can't be depreciate anything, so it'd be 0. But at the end of that year, it's gone down by 5,600. At the end of that year, it's 85,000. After first year, because it's gone down 5,600, and it's going to be worth 79,400. And then the following year, same thing, 5,600 down. But how much it's depreciating each year, you're adding up. Part A, okay, use the table, find by how much office furniture has depreciated after 3 years. So we're looking at the 3 years here, not the value, how much it is now, depreciated. It's $16,800. It depreciated in 3 years. And 7 years, this how much is depreciated? $39,200 depreciated. Salvage value, how much is worth now? So 3 years, it's worth $68,200. In 7 years, it's worth it now. After 7 years, $45,800. The furniture's value after 10 years by continuing the table for a further 2 years. Okay, let's have a look. Accumulated depreciation first. So we keep adding on 5,600. We have to add 5,600. It depreciated $50,400. Following year, you'll add another 5,600, $56,000 depreciated in 10th year. Here on the other side, it is minusing 5,600 each year, going down minus 5,600 here, minus 5,600, and it'll be worth 34,600. And then the following year, the 10th year, it's going down by 5,600 again. It is worth now 29,000. After 10 years, it's worth $29,000. Now, interesting. Construct a straight line graph with year on the horizontal. So that's how many years, the X values. The value, the money in a vertical. On the side is money in its years. We got to plot all these numbers. So we are expecting this to be something like that, going down. Look, X and Y. Years is X. How much is worth? That's our points. 1 and 79,000. roughly here. Okay, and 2, 73,800, something like that. 3, 68,200, something like that. 4, 62,600 here. 5, 57,000 roughly here. 6, roughly like that. When you join them together, it will look like this. Okay, next one. Use the graph to find. We are looking for value, the Y value, the money, to the nearest $1,000 after 4.5 years. 4.5 is right there. And I'm going to go all the way up, and then I'm going to hit that note and go to the left. I get $60,000. Okay, the next one. After how many months? We need to convert years to months. 38,000. At 38,000. Let's have a look at scale. So roughly it's 2,000 each. Roughly here, 38,000 is 0.2 each. I'm going to hit with the 2 spaces, which meaning 8.4. So it'll be 8.4 years, and I need to convert that to months. It'll be 12 months, which will be 101 months. Okay, so it was roughly 100.8 months. It might not be 38,000 down. So I want to make sure 38,000 or lower. So I will say 101 months. I think that's the end of the example for today's lesson. Okay, well done, people.